Hi guys, Education Fear welcomes you to Reflection of Light by Different Surfaces Part 2. In the last session, Part 1, we have discussed what is center of curvature, focus point, focal length, radius of curvature, what is principal axis, image distance, object distance and all. So if at all you would have not learned all those things, please go through that and come back to the Part 2 so that you will understand all the sessions easily. In this session, we'll be covering few topics, that is ray diagrams of concave and convex mirrors, and what is real image and virtual image and their differences, and concave mirror and convex mirrors and their differences, and the uses of the spherical mirrors in our daily life also will be discussing in this particular video. Let's start with the concave mirror. See, look at this. Usually concave mirror is a part of a spherical mirror. Okay, it is the inner part of this mirror, we call it as a concave part. It is bent inwards. Okay, when the rays fall on this, what happens? It will reflect back and meet at a point. So this point we call it as focus point. You can see in this diagram, this is a focus point. All these black color lines are the rays which are falling on the concave part of the mirror and they're getting reflected back. The red color lines are reflected rays and meeting at a particular point, that is a focus point. Okay, let's come to convex mirror. A convex mirror is a divergent mirror. That means, see, it is also a part of spherical mirror, but the reflecting surface is the bulged one, this part. Okay, so now when rays try to fall on this particular bulged part, this part, okay, look at the diagram, the blue color lines, whatever you are seeing here, this ray, this incident rays, when it is hitting this convex mirror, what happens? It is getting reflected back, the red color lines. Okay, these are reflected lines. So when they reflect, actually when they are getting diverged, we will extrapolate these lines. You can see these dotted lines, right? These lines. So when we extrapolate this, we are all the rays are meeting at a particular point. This point is called focus point. This is how we'll find out the focus point of a convex mirror. And it is a divergent mirror. Concave mirror is a converging mirror. That means all the rays will get converged at a point, and here all the rays will get diverged. The ray diagrams of concave and convex mirrors. See, we have three rules in it. The first rule is when a ray passing parallel to the principal axis. See, this is the ray R1 which is passing parallel to the principal axis. It is reflecting and passing through the focus point. Okay, it is passing through the focus point F. This is concave mirror. Okay, and here this is the ray, yellow color ray, this is R1, ray 1. When it is passing parallel to the principal axis and hitting the convex mirror, it is getting diverged like this, right? So when we extrapolate this line, it appears to be passing from focus point. This is the first rule. You have to remember like this: when a light ray passing parallel to the principal axis, it moves or it passes through the focus point in concave mirror. Whereas in the same case, in the convex mirrors, when a light ray is passing parallel to the principal axis, it diverges, right? So when we extrapolate, we are getting a focus point. So the saying will be like this: when a light ray is passing parallel to the principal axis, it appears to be moving from the focus point in the convex mirror, is the first rule. Next comes second rule. See, if a light ray is passing through the focus point, it passes parallel to the principal axis. Here in the concave mirror, even in the convex mirror also, see, look at, even in convex, this is convex. Okay, if a light ray is passing through the focus point, that means which is appearing to be passing from the focus point, moves parallel to the principal axis. Okay, this is the second rule. First rule is a light ray which is passing parallel to the principal axis moves through the focus point, and the second one is if a light ray is passing through the focus point, it moves parallel to the principal axis, vice versa. Okay, next comes, it's a very easy rule. when a light ray is passing through the center of curvature, it bounces back. That means it moves in the same path. Okay, here you can see this. Okay, here also, if a light ray is passing through the center of curvature, it bounces back. It's a very important question. From these three rules, you may be getting 1 or 2 mark questions to complete the diagram. Okay, now coming to concave and convex mirror uses. As we have discussed just now, concave mirror is a convergent mirror, right? All the rays will get reflected there and meets at a point. And as usual, convex mirror is a divergent mirror because all the rays are getting diverged, right? So next comes real images are formed in the this concave mirror, and virtual images are formed in the this convex mirror. How? I'll explain you. Just a minute. Yeah. See, this is a concave mirror. This is our F. This is our C. Okay. My object is here. Okay. When a light ray passes parallel to the principal axis, it moves through the focus point. Similarly, when a light ray is passing through the focus point, it moves parallel to the principal axis. So my image formed is here. This is object and this is image. My image is here. Now look at this. A concave mirror is giving you a real image which is in front of the mirror, right? And it is inverted. Okay, which is inverted. That means this is O dash, inverted in the sense this is O dash and O, reverse matter. And next comes what is how the image is formed in the convex mirror is like, look at here. Let us take, this is our mirror and this is a principal axis and this is a object. Okay, when a light ray passes parallel to the principal axis, obviously it gets diverged like this, right? That means it appears to be passing from the focus point, and this is a center of curvature. This is one line, one ray. And when another ray, a light ray is passing through the center of curvature, again it bounces back, right? Here this is the extrapolated line and this is the center of curvature line. Both met at one point. Whenever the two reflected rays meet, there we will get the image, right? So here we got an image which is backside of the mirror. Actually this is a reflecting surface, right? But we got image here, and which is erect in the sense straight. We got image like this because object is also like this, and which is formed backside of the mirror. That is why we call it as, it is a virtual image and it is erect. Hope you all understood. Yeah, so it is a virtual image and it's a erect image, it's a inverted image. Now image looks much bigger than actual size. As I've discussed just now, in the concave mirror, usually concave mirror gives you a bigger image, okay, whereas this convex will give you a smaller image than the actual size of the image. This is a real and this is inverted, except in the case of this in between the pole and the focus point. That means if an object is placed like this, one second, this is an object, okay, this is pole, this is F. If you place the object here, you will be getting image here backside of the mirror. So except in this case of concave mirror, all other cases, in all the cases you will be getting the inverted image and the real image only. Okay, here in all the cases convex mirrors, the virtual image is formed and it will be erect only. Okay, usually concave mirrors are used as a headlights, reflecting telescopes and torchlights, because it focuses all the rays at one point. So actually we use headlights for focusing the all the rays of the light, right? And whereas convex lens is used as ray side view mirror of vehicles and optical instruments and calling bells, because usually convex mirrors are like is used as a side view mirror, because we wanted to see the objects which are coming from the back in the mirror in a smaller size. So obviously convex mirror will give you the smaller size than the actual size, right? That is why it is used as a rear view side mirror. Next comes to uses of concave and spherical mirror. As already we have discussed, few more important uses in our everyday life we'll be discussing here. Concave mirror as used as makeup or shaving mirror, because in order to see the objects larger we use this concave mirrors. And and reflector in torch lights as a focus lights to focus the light, and in the headlights in order to see the vehicles. And it is also used by ENT doctors to examine the parts easily, so that it gives you a larger image, so that we can see all the small parts clearly. And the large concave mirrors are used to concentrate sunlight to produce heat in solar cookers and solar furnaces, because all the rays will get converged at a point, so that it generates heat there. Okay, that is why we use a concave mirrors there. And coming to the convex mirrors, it is used as reflectors in street lamp. This it's like, a street lamp will be like this. It diverges the light in different directions. In order to diverge the light in different directions, we use convex mirrors there. And it also used as rear view mirror. It is also used as magnifying glass, and sunglass is also used in sunglasses and also used in telescopes. Okay. And next topic is real image and virtual images and the differences. Usually real image is formed in front of the mirror and virtual image is formed backside of the mirror. I'll show you. Just look at here. So let us take this as a mirror. If the image is formed, see, this is an object. If an image is formed in front of the mirror like this, it is called real image. If an image is formed backside of the mirror like this, it is a virtual image. Always virtual images are erect, and this real images are inverted. So as we have discussed already in the difference between concave and convex image mirrors, and here it is formed when two reflected or refracted rays meet. This I'll show you the diagram. Yeah, so this is a mirror, focus point, this is pole, this is a object. Okay, light rays passing parallel to the principal axis, passing through the focus point, passing through the focus point and moving parallel to the principal axis. My image is here. Okay, it is formed in front of the mirror and it is inverted, right? So what is the point? Formed when reflected rays meet. See, when reflected rays meet, when two reflected rays met, we got a image, right? So usually when reflected rays or refracted rays meet, then only we'll get an image. In case of this convex, what happens, usually this mirror won't give you a direct image. Okay, it gives you the image when the rays are extrapolated, as I've discussed just now. This is our object. When it moves parallel, it appears to be passing from the focus point, and This is a center of curvature. Another ray is moving like this, okay. Obviously it bounces back. So this is the ray, right? It is moving. Both have met here. When two reflected rays met, when extrapolated, those rays have met here. So this is where the image is formed, okay. Next, so obviously it is inverted image and this is erect image. Virtual images are always erect and it is inverted. A real image is created when rays of light converged by a concave mirror. Obviously concave mirrors always give you these real images, except when the object is placed between pole and focus point. Whereas in the virtual image is created when rays of light diverge from a convex mirror. That means virtual image, always convex mirrors will give you virtual images itself. Hope you all understood. Thank you.